Now we are going to look at the infinite geometric series. So that's the keyword, infinite. Infinite means you are adding numbers forever. Let's see what we know so far. So the first term is of course 2 plus the second term I will multiply by 3, I will get 6. The third term I multiply by 3, I get 18, and that's it. But this is called finite sum. Why? Because it stops here, because it is telling me I have 3 terms. After 3 terms I have to stop and then find the answer. It's also called partial sum. Basically here I have S3. This is S3. If I say S4, then you will add the next term. But what if I say S to the infinite? That means I have 18 times 3, that would be, keep going forever. And what is the answer? That's what the infinite geometric series is all about. So this is the infinite sum. Finite sum or partial sum, they stop somewhere after some terms, but infinite sums go forever. Now look here, I put infinity because I want it to go forever. So once I do that, there is no end to these numbers. So what happens when I do that? So I want you to realize this. The number that I'm getting is always bigger than the previous one, right? The number that I'm getting is always bigger than the previous one. So when I keep adding, the final answer will be infinite, because these numbers will keep getting bigger and bigger and bigger, and there is no stopping. So that means this series, it diverges. Another way of saying it is the series is divergent. In other words, what does that mean? The sum does not exist. As long as you see that these numbers are becoming bigger than the previous numbers, that means the sum does not exist. Let's think of another one. What if I do like this? This time I change the common ratio, I make it -3. So what will we have? We have 2. Think about how these numbers are changing. So think about what's happening to these numbers. It's like I'm starting at 2 somewhere, then I go down to -6, then I go up to +18, then I go down to -42, which is bigger. Then I go up to, it becomes a much bigger number. So basically it looks like this. It just keeps going like this, and there is no stopping. So the series diverges. There is no sum, okay? Because again, the next number is always bigger than the previous number if you ignore the negative, if you just think about the absolute values. So here is the hint. Here I have the common ratio equal to -3. In the previous example, we have the common ratio equal to 3. Anytime you see the common ratio or the absolute value of the common ratio bigger than 1, you will have a divergence. In other words, if I have a number line like this, that's 0, that's 1, that's -1. If the common ratio R is here, or here, like 3, just like we saw, or -3, okay, the sum will diverge. But let's see what happens if the common ratio was here. What if the common ratio is between -1 and 0? What if the common ratio is 1/2? What if the common ratio is 0.7? What would happen? Let's look at an example like that. Okay, let's see what happens then. So I'm starting from 16 plus what? Half of 16, that would be 8, plus what? Half of 8, that would be 4, plus 2, plus 1, plus half, plus 1/4, plus 1/8. Now look at these numbers that I'm adding. Each time the number that I'm adding is half of the previous number. The number that I'm adding is half of the previous number. Because the number is getting smaller, if I keep adding to infinity, I will get to a point where I'm adding numbers that are extremely small, like 1 over a big number, because remember, these numbers at the bottom are increasing, which makes the whole thing very small. And what happens? This will be like adding 0. In other words, here the series converges. Let's do it again over here. Let's try to apply the formula. So I have s to the infinity is going to be a1, that's 16, times 1 minus r, that's 1/2, to infinity divided by 1 minus 1/2. So I want you to think about it. What is 1/2 to infinity? In other words, what is 1/2 times 1/2 times 1/2 times 1/2? Suppose you keep going forever. What do you think we get? 1/2 times 1/2 is 0.25. Times another half is what? 0.125. Times another half, what do I get? Times another half times another half, what do I get? The number becomes smaller and smaller and smaller. What if I keep going? What if I keep going? What if I keep going toward infinity? The number will eventually become what? This whole thing, I don't need it anymore. So my answer will be 16 times 1 over 1 minus half. And I will get 16 over 1 minus 1 half. That is 16 over 1 half. That would be 32. That's it. The series converges as opposed to diverges at 32. So let's look at the formula again. We know that if I change this to infinity, this whole thing becomes 0 like we saw it, as long as of course r has to be between, because that's when it's convergent. Okay, so that means the infinite sum of any convergent geometric series is going to be a1 1 over 1 minus r. So this is r. You can also rewrite it as a1 on the top over 1 minus r.